Welcome everyone. My name is Sonja Zaki. I'm a journalist with the online media Uusi Juttu and your host for today's opening episode of MAGICS, Human in the Digital World talk series here at Aalto University, which is also my home university. The MAGICS talks are organized by the host universities of the MAGICS national infrastructure. Please do take a look at the website for more details. Today we will be diving into digitally augmented clothing. How do garments transform into interactive, data-rich experiences capable of monitoring our well-being? Have you ever wondered what happens when a glove not only just warms your hand, but also tracks your heartbeat and posture at the same time? Or what does sustainability look like when electronics are stitched into your clothing? What ethical questions arise when clothing can collect and transmit personal data? We will have an eminent guest joining us here today. Professor Yu Xiao leads the Wearable Systems Lab here at Aalto University and is a pioneer in making these visions a reality. She will reveal how technology can be integrated into our daily lives, medical settings, and beyond. Unfortunately, Sofia Pantuvaki, professor, was unable to join us today due to a cold. The event will go as follows. First, Markus Korhonen, the director of Aalto Studios and the technical director of MAGICS, will tell us all about the MAGICS infrastructure and the talk series. Then Professor Yu Xiao will give her own presentation, and after that, I'll interview her on stage. The audience here and watching the stream can send questions online throughout this event. The link can be seen on the screen. Prepare for a fascinating journey into the future of wearable tech and digitally augmented clothing. We're thrilled to have you here with us today. Let's start. Markus Korhonen, a warm welcome on stage.
Welcome to everybody on my behalf as well. I wanted to take this opportunity to open up what MAGICS infrastructure actually is. It is an infrastructure that we established in 2020. The name comes from the words media, arts, games, interaction, computing, and science. Our infrastructure aims to digitalize and virtualize the world, but with this idea that we always keep human in the center. Because we're an infrastructure, we provide infrastructure services, we have facilities and equipment for 4D digitization and virtualization, and then measurements of collective and individual human experiences. Here's an example project. What do I mean? So let's see that. this pilot project nicely shows like how we in MAGICS want to bring together art and technology and science. So here together with the Finnish National Opera inside their digital twin, we created this dance performance, and then we measured it, how people actually experience that. So the idea is that with our tools and our infrastructure, we enable new ways to create art, and we want to create new ways to create science, and then we hopefully can bring them also together in projects like this. So this was a pilot project, and currently we also have another project going on with the Finnish National Opera, which is the Extreme European Union Horizon project with Professor Robin Welsh and Professor Mikko Sams from Aalto University. To digitize, we've acquired technological tools. We have scanners, like LiDAR scanners, where we can scan the environment. We've got individual scanners. We've got motion capture systems, different sorts of these systems to digitize human beings and their environment. Then we have a system where we can virtualize these digitized worlds, present them in different ways, in VR and in other means. And then we are developing human measurement capabilities in Aalto Behavioral Laboratory, which is part of the Aalto Neuroimaging infrastructure. So our aim is that we can digitize humans, the world around them, but then also the internal world of human beings, so that we can understand how digitalization also affects humans. So if we look at the research areas of our partner universities, we've got enabling human technology interaction, ensuring sustainable livability, digitally augmented learning, AI in design research, publishing, digitally augmented art, measuring human behavior and experiences, metaverse, so really the full spectrum of digitalization and virtualization. And whenever we do that, as we state in the title, it's the human in the digital world. So we want to really consider the effects on individual human beings and humans as collective. So that digitalization is not something that happens by accidents, but it's something where we actually research and measure the effects of digitalization so that we can be sure that this digitalization can be for the betterment of humanity on this planet. What we want to be, we got on this Finnish Academy's infrastructure roadmap in last December. So we are now one of the 21 infrastructure in Finland on this Finnish Academy infrastructure roadmap. And our aim is really to build a world-class, large-scale contributor for the creation of the sustainable digital world. And in order for that happen, it's not only about the technologies, the buildings, the infrastructure, but the community of researchers and artists who then actually do all the projects and the research in our facilities. In Aalto, Aalto MAGICS is located in two organizations. It's in Aalto Studios, where we handle the audio-visual side of the digitization and virtualization. We've got facilities in this Marcia building like the digital studio with a fantastic motion capture system. We've got visualization studio upstairs with the shared VR space, XR studio. We've got a film theater with the virtual acoustic system installed by the Aalto Acoustic Lab. And then we've got the Aalto neuroimaging infrastructures, Aalto behavioral laboratory, measurement rooms and control rooms in this building for human measurements. And together, we bring our expertise to really create these fully digitalized, but then also measured digital experiences. So why are we doing these MAGIC talks? What's the idea behind these? This is about community building. So these are actually from our MAGICS consortium strategy. So in order for us to succeed, we need to be able to build a community of researchers, educators, and industry professionals who are really sharing the same vision with us. So that's why we are organizing talks in all of the consortium universities. So this year, we will organize 6 talks. We are starting the series here in Aalto. And then all of our partner universities will host also their talks. And all of our talks will also be streamed online so that we reach to the wider community also outside just our academic institutions. And it's not limited only to these talks, but we are also organizing other events. So for example, we organized an event in February related to the investments that we will be making on this investment money that we got from the Finnish Academy when we got on accepted to the roadmap. So we invited researchers, industry people to meet us here in Marcio, where we talked about, okay, this is what we got for these investments and what are actually your needs as researchers and artists. What do you think that we should enable for you with this money? So altogether, we actually got for the whole consortium, we got 7.6 million approximately. So that's shared between the different universities. Here in Aalto, we got 565,000 euros for the human measurements part. Some of that is actually integration work for our existing Soile platform, research platform. And for Aalto Studios, we've got a XR and visualization investments. We actually got 985,000 euros. Obviously, this is not something that we're going to spend immediately, but this is money that we will spend over the years when we are now on this roadmap. But this money, this is not for us. This is for the community. This is for the researchers and professors that we have here. This is for the practicing artists in our community. So please be sure to get in touch with us. You can find all the contact details for us here in Aalto and for all of our partner universities on our website. And don't hesitate. Contact us, follow the website, because we will be organizing events, reaching out to community to learn about the needs that the community around virtualization with human in the center really is looking for. Thank you.
Thank you for a wonderful presentation, Markus. Next, I'm inviting Professor Yu Xiao on stage. She leads the Wearable Systems Lab here at Aalto University and stands at the forefront of the intersection between wearable tech and human-centric design. Her research focuses on the Internet of Things, smart garments, and sensor-based applications that enhance health, well-being, and beyond. At the core of her research is the commitment to harness technology as a positive change in society. Her team's prototypes emphasize practicality and user-friendliness. She's interested in collaborative projects where engineers, designers, and artists all unite under the same shared goal: to enrich daily life through inventive digital capabilities. Welcome on stage, Professor Yu Xiao.
Yeah, good afternoon, everyone, and thanks, Sonia, for the introduction. And as a member of this MAGIC community, I'm very pleased to come here to share what we are doing at Aalto Wearable Systems Lab. And as just mentioned by Sonia, so this is a multidisciplinary group, and we work on future wearable devices and applications. And specifically, we try to combine AI, extended reality, wearable sensors, and haptic to solve real-life problems, especially in the fields of healthcare, smart manufacturing, and beyond. And today I'm going to talk more about smart garments as a digital interfaces for extended reality. And when talk about extended reality, we know that it's becoming mainstream. It actually brings a significant benefits already for the many industries and sectors. Virtual reality, for example, has become a very useful tool for rehabilitation, for employee training, tourism, and also cultural and heritage. And if we think about the mixed reality or augmented reality, they have shown great potential in assisting people with like memory disorders, visual impairment, and of course they could also enable like engineers to work more efficiently during their construction, assembly, or maintenance processes. So before we dive into our research work, I would like to kind of take a moment to kind of consider how we actually interact with virtual environments today and what type of user interfaces are available. And actually, there are a variety of methods. So, for example, I think many of you are familiar with what I have here. Right? So when you think about extended reality, especially virtual reality, then people immediately think about VR controllers like this. It has buttons, it has these triggers, thumbstick. Of course, it also has sensors actually embedded, so it can track also your hand movement and try to translate it into some actions in the virtual environment. And we can also use speech to give commands. We can also be using the sensors embedded in our headset to detect our head movement because it has the motion sensor embedded. And nowadays with the modern headsets, you could also use the cameras to track your gaze movement, so know where you are staring at, what you are interested in. And with some cameras, for example, on MetaQuest, it could also track your hand gestures. And of course, they usually only support predefined gestures. For example, if I want to select or open application, I just point and then I pinch. Or if I use pinch and like a drag to kind of scroll up and down, left and right. That is what we have. And then you will say, yeah, if we want to track how we move, our full body motion, we have this very fancy suite you can put on, right? You might have seen it in some virtual theater in those applications. But then the question here is that, are these all? And are these all good enough? And are there any other solutions? Why I ask, are these good enough? Because we think that although all these tools, they have advanced our interaction capability, there exist still limitations. Let's take the camera-based, like a hand gesture as an example. So if your hand or maybe some objects just block the camera view, you will lose the tracking. And also this kind of camera-based system is very sensitive to lighting conditions. So that's why we need to think, is there some other solutions? And one alternative is going towards wearable interface like sensing gloves or sensing garments. So instead of using something like this, we would like to have something that will support a more natural interaction. So Back into 2020, so we began to develop our kind of the first sensing glove in the group. And at that time, we tried to develop the gloves for virtual stroke rehabilitation. So the whole project is actually about virtual stroke rehabilitation, including exercise games in the virtual reality to encourage people to practice more, and also the sensing gloves and the garment to kind of track the motion to make sure that people are actually moving in the right way, because we need to make sure that they don't develop compensatory movement. That's not what we want. And as you can see, we cannot really ask the stroke patients to use the controller, because they need to actually rehabilitate and learn to use their hands again. And you ask them to use the controller, this sounds something like really challenging for them. So then we come to the idea is that what if they don't need the controller, they just use the glove, and what can they do? And on the other hand, we know most of the rehabilitation exercises are very boring. You ask people to go there and they say, raise your arm, you know, no wonder people got bored there. So we need to have the exercise games. And the idea is that can we try to translate those exercise games into more interesting daily activities? And this fixture on the back, this actually is a magnet. So these measuring coils inside this conductor will actually measure the magnet field generated by this magnet. So when you are moving, obviously, the measurement would change. And based on these results, we develop the machine learning models to calculate the finger position and also the rotation. And when we have the 5 finger positions, we'll be able to apply like inverse kinematic to get the estimate of the foot hand. And sometimes, and by the way, this location, we got other location relative to the back of the hand. But sometimes in the virtual reality, you want to also know where exactly is our hand in this space. So that's why we still had these Vive trackers here. So just to kind of locate this whole hand in the virtual space. And this is one of the projects that we managed to reach pretty high, let's say, technology readiness level. So we basically went all the way from the more basic research to applied research and then the commercialization preparation. And we learned basically through our first-hand experience, like all kinds of challenges and complexities of making this kind of hardware products, because it's not just about the functionality, how accurate we can get for the finger tracking, but also the wearability of this kind of glove. So for example, it needs to fit people maybe with a different hand size, and ideally it should be very easy to put on. I have to admit that even the final prototype is not so easy to put on by the stroke patient, something still to be improved. And also this needs to be washable. So we can remove this this electronic components and put it into the washing machine. And we also studied like the manufacturability. So basically, how is the design good for or easy for manufacturing? So this is all we did for this project. But as you can see, this kind of glove, if you are just sitting on chair and use it for a while, you'll say, yeah, it's fine. But if you are supposed to wear it for many hours during the day, you will definitely complain because it's still bulky and heavy. So then if we think about other applications, for example, when we use mixed reality or augmented reality to help the engineers in the assembly work, then they want something light, much lighter, comfortable to wear. Ideally, it can be wear under their current working gloves. So that is not like the best option. So this leads us to explore the other field called e-textile. So e-textile work in the way that you could utilize conductive material like conductive fabric or yarns to create like sensors, actuators, antennas, and even energy harvesters. And they are definitely much softer, and you can also wash them, and they are like kind of, I think from the wearability perspective, it's much better. And you can see from my hand, so this is what I mean, what I like conductive fabric. So for example, this is a commercial pressure sensing fabric. So you can use this to generate pressure sensors or even bending sensors, because this is a piezo-resistive material. It works in the way that when you compress it, when you stretch it, or you bend it, the resistance will change. And then this one is like a sample of the conductive yarn, and this is something kind of coated with silver. So you could use it to replace the wires, and of course also to create the sensors if you want. Yeah. So then we made our first pair of sensing glove for assembly training, because at that time we had the idea that we want to create this kind of mixed reality assistance, or also a virtual reality application for assembly training. So there, we don't actually care so much the exact finger position. What we actually care is like what this person is doing. If it's an assembly task, what exactly is this person doing? Is it picking up certain tools or components, or is this person, for example, using screwdriver to tighten the screw or loosen the screw, things like that. So actually, it might be difficult to see from there, but this is actually the glove I was mentioning, if you can see. So on the back of the hand, we have the bending sensors on each finger, and then on this side, we have the pressure sensor. So as you can see also from the picture on the slide there. And this is the first one, and then I give you another example. So this is a sensing glove we developed together with Department of Nursing Science in Turku University. So this is for CPR training, and we all know that the CPR, especially high quality CPR, is very important first aid skill. And if you visit the medical schools or like a nursing schools, how they actually train the people, they have very expensive CPR training like equipment, even though it can give you really the real time. I mean, they can kind of assess the quality of a CPR, but it is really too expensive. It's not really suitable to train in large scale. The lay person, or if you think about some schools in developing countries, they really cannot afford that. So our idea was very simple. We want to make something affordable, easy to use, and also the technology-wise, it could become so simple that we open source the design so people can actually get these materials from the market and build it themselves. So that was like the CPR glove, and what we can do with that is that we have, for example, if you can see the right hand, so we would have the pressure sensors there, and then on the left hand, in that case, we still put one IMU there. So in real time, it can detect your compression rate, and also the depth, because you need to press deep enough also, and also the chest recoil. So your hand is not supposed to leave the skin and like a bouncing there. So this is what we can detect in real time, and also we connect this to the microcontroller, and then this could also provide the speech kind of instruction in real time to say, for example, you are too fast or you are too slow, please compress like deeper, like that. So this is the other example we have for the gloves. And obviously, we didn't stop there with the glove. So when we managed to make some glove, we started to think that, we want full body garment. And then, to be honest, we didn't realize that it's so much more difficult actually than making the glove there. Yeah. So as many other research groups do usually, when we move to full body motion tracking, we started with inertial measurement unit. So this is basically like accelerometer and gyroscope, this kind of sensors. And we use the commercial sensor, for example, like the Sundor Move Sense, made in Finland. And we put them on different parts of the body and try to collect data, try to understand where are the best places to place these sensors, how to train the machine learning models so they can give very accurate results and also resource efficient and like that. So we went there. But then when we were running the user test, actually last year, we did the user test with 13 people. We asked them to put on on it was like about 8 IMUs on the body, and then start doing some daily activities, like even like a walking, lying down, and doing some basic, cleaning, this kind of thing, just to see how they work. But what we have discovered from the user test is that when every subject came, it took almost half an hour for us to set up this system. Why? Because we need to use Stripe to place all the IMU there, and then to connect each of them to a phone or laptop and to synchronize them. So, and of course, we also need to calibrate them. So then we start to think that if we give such a system to an elderly, for example, if we want to use it for health monitoring home environment, how could elderly manage to put on this every day, and remove this? So this is not feasible. So we want something simpler. So then we're thinking can we replace the IMU, or at least some of them, with something soft and more comfortable? So we came back then to the e-textile. And when you come to the full body motion, we focus at the moment the joint movement, because if you think about the human body, if you are able to detect the movement of each joint, you basically can get an estimate of the full body pose there. So we started again with the commercial yarns, and usually those commercial conductive yarns, they were coated with copper or silver, like that. And nowadays we know that it's not nice to have those metal there. So we try to make it more sustainable. So very soon we kind of moved to the carbon-based material, and also thanks to our colleagues from School of Chemical Engineering, because they made those carbon-based materials. And we kind of work on the second phase. So we got this material and we try to fabricate those sensors there. And here is one example of this knitted bending sensors we made last year. So this was made from this knitting machine you saw on the slide, and only this black part is the sensor. So the way how you work is that you put it on, and then this black part is supposed to stay at the elbow. So now when you bend, so this resistance change, and then we will be able to estimate the joint angles. And because this is only the sensor, it needs to be powered, and we need to be able to sense the data wirelessly somewhere else. So you can see we still have some antennas, and then some microcontrollers, and we still need to use batteries. So I have to say these are still the challenges when it comes. So how to power this, and how to, if we can replace this whole part with something soft, that would be even nice. So this part of work is still work in progress. But I must say that the preliminary results look pretty promising. We are not that far away from this kind of wearable garment for full body monitoring, but it still would take a couple of years at least until something can really be used in daily life, because there are still many challenges, as mentioned, to be solved there. So this moment, after I introduced the sensors we developed in the group, I also want to mention that this spring is the second time we run this course called Smart Wearable. So we developed this course together with a design department. So the idea is that if this field, we see the great potential, a lot of application, but where do we have people to work on that? Because it required expertise from different fields. That's why we developed this basic course. It's open to all Aalto students, and they are designed to be beginner friendly. So students came and they learned the basic of e-textile, the electronic design, and also machine learning for the sensor data processing. So for example, this year we had 53 students in the course. So 14 groups finished their work, so they make their own smart gloves, some made smart socks, some make a smart insole. And they, of course, they came to the idea, is this glove for certain game, or is this socks just, for example, someone had this socks for detecting the football training, measure the football training like that. And on this slide, you see there was also one example. So it's one pair of gloves made by a group of students actually from ELEC and designed together. So at the moment, we have most of our students from ELEC and arts, and in the future, we hope to see more students also from other schools joining us. So as I talked already all about the sensors, so if we think about the digital interfaces, they are providing input. But how about the output? So we still need the output, we need the feedback. And at the moment for extended reality, we have the visual feedback, we have the auditory feedback, and they work pretty well. But something is missing, is the haptic. Because when we interact with the virtual objects in VR, for example, you don't feel it. How can we feel their size, their shape, their texture, or their weight? So that requires haptic interfaces, especially wearable ones, to replicate this kind of sensation of physical interaction with objects. And in the market, there exist some products, but not many. So for example, the haptX gloves and the Sensor glove is a Dutch company. They also produce haptic gloves. And then we have a Tesla suit. And of course, a couple more. But in general, not so many. And if we take the SenseGlove Nova 2 glove as an example, so they usually have the finger positioning function, and then they provide like a force feedback and a vibrotactile feedback. And they only work of interaction with the rigid objects. For example, you try to grab a cup, or if you imagine like some teleoperation scenario, you try to pick up something and then move this one from one place to another place, so you can feel the weight of this object. So this is a very typical scenario. And what we think is missing is like, if we think about the physical world, we also have liquid and gas, other kind of objects. But when you interact with those kind of objects, how would you then replicate the sensation there? So that actually inspired us to develop a smart garment to replicate the sensation of hot steam and cold shower in the virtual sauna game. And we did it in an ongoing EU project called the European Media and Immersion Lab. And that project started about 2.5 years ago, and now it's going to end very soon. And in this project, as I said, we make something for the sauna again. We really like sauna here in Finland, and I think it's also the perfect application for our research field. But before I introduce the garment, I would like to show you a short video. So this, by the way, this is the key researchers for this project.
Hey, I'm Tim Mürsken, and I work on EMIL's Lighthouse project Smart Garments. In this project, we have developed a thermal and haptic interface designed to create immersive VR experiences by stimulating the senses of touch and temperature. We have created a hardware-software infrastructure featuring a modular, wearable, and flexible system for vibrotactile and thermal actuators. This includes the design of electronic components and PCBs, garments and textile structures for wearing it tightly on the body, an open API and control system that seamlessly integrates with VR game engines such as Unreal Engine. On the experience side, we have focused on achieving liquid thermal sensations like the feeling of wet, hot steam and cold water. These are showcased in our model VR experiences, a traditional Finnish sauna. Right now, we're conducting user studies to evaluate the wearability of our system and the haptic experience.
Yeah, so actually today we also brought this one here. You can see this is actually the garment. When we designed that, the first question that came to our mind is like, how do you generate temperatures? So we actually compare the different solutions like a heating pad, heating yarn, and at the end we end up with using something called a peltier. So because it can generate both heat and cold, and also you can change the temperature much faster than the other ones. And as Tim also mentioned in the video, so we work also on the software like APIs to control this. We can configure different kind of activation patterns when you have several of these peltiers on your arms or on your back, like that. But I would say most of the time, we actually spend on exploring the experience. Because even though we have been to sauna, but if we ask you, how do you express your sauna experience? How would you describe your sauna experience? It's not easy, right? So we did actually the first user study by going together with the subject to the sauna, and then try to figure out how people would actually describe the sauna, how the sauna actually experience look like. And we figure out, for example, something very important. Sauna is not just getting something hot. It's something about you can feel the heat transfer across your body. And that inspired us to come to the different activation pattern design later. Okay, so as I have introduced like a different works about the sensing and haptic, and what are we still doing now? There's still a lot of things to do. We continue developing the sensors through the collaboration also with material scientists and designers, but we also see a lot of challenges in the design process, because the smart garment, the design, is still following the traditional trial and error process. Of course, it goes through many iterations. Every time you make the sensor, you try to put it somewhere integrate into the garment, you recruit the human subject, you make the test, and then you collect data, you train AI, and then you figure out, oh, something wrong, and you go back. And this is very, let's say, labor intensive, and it takes a lot of time. So now what we are trying to do is try to reduce the manual effort by introducing simulators to the process. So can we try to simulate different motions? Can we, for example, try to simulate the sensor behaviors, so we don't necessarily need the human subjects in this the process, and I mean in most of this iteration. So that is something we are trying to do. And then on the haptic side, we are trying to work on customizable haptic feedback, because for different users, even for sauna, you need to tune it. And then we also try to understand how people respond to different haptic feedback, especially the emotional response, and can we try to adapt our haptic feedback to people's emotional response, because there might be a useful feature or important feature for the effective wear application, for example, for rehabilitation or for some mental well-being related applications there. Yeah, so we are still on our way, and we would like to collaborate also with people from different fields, because we believe there is a great potential and a bright future here. Thank you.
Thank you for a fascinating presentation. Next we'll have an interview section, but before that I'd like to remind the audience here that please do send your own questions. You can participate through the link which is soon seen on the website. To me, it seems that there are many different possible use cases for wearable tech in clothing, but when we think about the societal impact, where do you see the greatest potential?
I would say that at the moment, of course, usually when this kind of product came to the market, usually the first place people try is like a creative industry, right? Something very cool and fancy. But I personally see the great potential. One is in the health monitoring. Because if we think that the society is aging, the population is aging, and a lot of people will prefer to stay at home instead of going to stay in some senior care center like that. But we would like to be able to continuously monitoring their health status, including, for example, how they move, because that might become an early sign for certain diseases. So instead of waiting until you get ill, it's better to do it, like to prevent it to happen. So I think that is definitely one. And the other, I would say, like education and training. Education and training, because quite often we know that what is the best way to learn is learn by practice. But sometimes something is difficult if you only see a video, right? Like, oh, this look like that. But if you have the sensing, for example, glove, you can sense how you do it, and you can get the feedback, like not just visual and audio, but also haptic feedback, then you might be able to learn faster. And I think that would also benefit a lot, like a lot of industry where you need experienced workers.
Are there already some examples of that internationally that you have been following?
Yeah, so at least for health monitoring, there are mainly, I would say, kind of like not two categories. So one is like in our group, we focus more on the physical activity. But the other string, they focus on monitoring your physiological signals, like your heartbeat, maybe your blood pressure, your breathing, and this kind of thing. And of course, nowadays you could even try to detect your glucose levels, to analyze your sweat. So there are also people working on that. But I believe that these two streams will need to collaborate to work together. If you think about people's health, it's not just sweat analysis, or it's not just about how you move. So we have to combine them, also with other medical data we have.
That was a great point, and it got me thinking about. So we already have many, wearables that we can use to track our health, like rings and watches and so on. But do you think there is a point where the monitoring goes kind of too far, that we become too interested in things? And where do you see that point being?
It's true that, sometimes people say when I have a smartwatch and then I keep watching, checking how many steps I have walked, right? And then some people introduce this kind of social competition, or what you call even how many steps you walked today, how many steps, or pay too much attention to this this kind of quantitative figure there.
Yeah.
But I would say that if we think from other perspective, if you are able to combine this data, and sometimes actually as end users, we cannot really interpret the data. We are not professional. If you just collect how you walk, if we are not professional, we really cannot tell much. But maybe this will be very useful for professional healthcare, for the clinic researchers like that. So I think it might need certain point that we don't care so much about the raw data we get, or just a simple statistic, but more what this can tell. And maybe just at a certain point you get some notification, but you don't need to check it every day.
Yeah. Yeah, and now as we talk about data, I was wondering, how do you see the ethics, or what ethical questions or issues arise when clothes can track or monitor or collect and transmit personal data?
Yeah.
How much do you think about that in your work?
Well, I think first of all, data itself there's nothing wrong to collect the data, but the problem usually comes from how you use the data. And then, of course, and also whether you manage this data in the way that people can trust it. For example, we also have all our medical records stored in some online system, and usually we trust that the data is secured and it will not be shared. But at the moment, for the data collected from wearable devices, let's say if you have a watch, then the data is maybe the watch manufacturer or certain kind of service provider. So they are, first of all, they are in different silos. They are not integrated somewhere. And at the moment, the data is typically sent all the way to the cloud, and that is something make people worried. The data is somewhere out of my control. But I think now there are also people try to work, first of all, from the AI technology. So instead of sending all my raw data to somewhere that I might not trust, can the data be processed locally? So it means that the data will not go out of my own devices. It can be processed there, and then it can be decided later or by user, whether I want to share this data with my doctor or with my family member. So you will be able to control there, and you understand where your data go. I think that's the important thing. So technology-wise, we need to have solution, but otherwise, for example, the regulation-wise, there should be also a practical solution. It's not just say, no, you need to protect, but how? Yeah.
Do you see any other ethical questions when we talk about wearables besides the data question?
For the ethical perspective, or more general, I think it's when we are designing this kind of thing, we need to make sure that our design is inclusive. It's let's say when you design something, it's not just for example, it's not just for one group of users. So you need to consider that the people have different needs and how you fulfill the different needs there. I think that is a very important thing, because earlier when we work on AI, people have been criticizing, right? So when you train on certain kind of data set, they were perfect for this user group and not for the others. So when it comes to wearable, this problem is not going to disappear, and it might be even more difficult to solve, because if you think about, you do face recognition, most of human, we look similar. We all have two eyes, one mouth, one nose. But if you think about how you move, how you walk, that could be everybody is different. And it's very difficult actually to let's say, to make sure that it works for everybody that you have never seen during your model training phase.
Yeah, and in your presentation you already discussed the challenges that arise when you design pieces of clothing that have electronics stitched into them. But how much do you think about aesthetics? Do you think about that?
We try. But usually if you work as an engineer, that is not the first thing that goes to your mind. So we first think is how accurate is our algorithm and things like that. But at least, as I said, the Aalto Wearable Systems Lab, this is a multidisciplinary group. In all this project you have seen today, we have designers involved. So we have textile designer, interaction designer. So we have designers involved. Like the garment you saw there, actually the pattern or the prototype, this part was made by our student from the design department.
Yeah. What trends, if we think a bit further, what trends do you foresee in this field? Like earlier you spoke about how medical settings is a important field, but do you have thoughts on where the whole field is going?
I think at the moment there is one important trend is going towards a sustainable one, because as you can see the existing commercial solution, they are usually using like this kind of silver coated or copper coated yarn or fabric, and this is definitely against the current trend towards the sustainability. So how to replace them with, for example, carbon-based material, that is definitely one trend. But at the moment it's still in the lab, I would say, at a very early phase. And also the other one is how to improve the durability of this kind of thing, because we know for e-textile one problem is that if you wash many times, it's just not sensitive anymore, and we definitely want it to last a longer time. And sometimes we know that the clothing might got broken. Instead of just throwing the whole piece of garment away, how to make it so that it's easy to be repaired, or maybe it can follow certain modular design that you can replace part of that. So from design perspective, this kind of modular and more sustainable design, I think that is the other trend there. And the third one, I think, is more like the technology-wise. We still have for electronic engineering and the data scientists. So for example, you see still the wires there. We still have the microcontrollers and batteries, but how to replace them. That is other things to solve as well.
Yeah. How big of a topic is sustainability in your field? Is it a thing that is regularly or constantly discussed?
Yeah. Nowadays, well, I can say that in every funding proposal, I'm sure sustainable is mentioned, right? But of course, we see sustainability from different perspectives. Like environmental sustainability is one thing, but the other thing we see is also like a social sustainability. As I mentioned, like for example, the inclusive design is also part of the social sustainability. And also with this kind of smart garment, you can imagine that maybe some people living in the area that they don't have sufficient medical services, this could be something useful. Otherwise, you need to travel a long way to hospital, for example, to do some simple health checkup.
Yeah, this is clearly a multidisciplinary field, but could you explain what is the role of collaboration across disciplines, so engineering, design, in this field?
So I can give you a simple example. For example, we work with chemical engineering here. So they make the carbon-based yarn. And for them, they try to say, okay, I have this yarn, the sensitivity and so on, what is the sensing range like that. But they may not know very well, like, is this good enough or is this suitable for certain applications? And then we need engineering to come in and say, hey, now this is the material you have, and we try to make the prototype to make this some application, and we provide feedback to them. We say, hey, by the way, this yarn, maybe the sensing range is not enough, maybe this sensitivity is not high enough or something. So we will be able to give feedback to them. And of course, with the design is also very important. So as you said, we engineer usually focus on functionality, but at the end we just prove that, okay, these functions, we can implement this kind of technical features, but how to build a user-friendly application of products, we will need a designer there. And then at the end, it's again the feedback loop. So finally, it will be, if there is a real-life problem, designers come in first. So they figure out the user needs, what are needed. They give this information to engineer. We make it, and we give feedback to the material scientists. So that's like all the way like that. And when the material science say, oh, now we have breakthrough, everybody's happy. Let's try again to see what can we do, with that. Because that is, I don't think it's always there is a problem and for sure at the beginning what are the solutions. Sometimes it's also technology driven. When there is technology, we try very hard to think what would be the applications there.
Correct me if I'm wrong, but there probably isn't many places in the world where you can study this specific field. So how do you educate more people to this field who are able to do things that you and your research group are doing at the moment?
I can say, you saw, we have this now, the smart wearable course, and 2 years ago there was no such course. And why we wanted to have this course, because since we founded this Wearable Systems Lab, every time when we need to hire a research assistant, we couldn't find suitable candidates. Or let's say it ended up in the situation that within Aalto there are maybe less than 5 students who can do it, and then there are many research groups who need them. And then one research assistant will be assistant for several groups. That never happened in other fields, I would say. So we often need to fight to say, can she work 20% for you, 14% for me, and then they say we have only 100%, so it's not enough. So we realized that we don't have people, and then we talk to both arts and chem, and and then we try to sit together, the researchers, and say, if we need to find this pool of people, and we need to train them, we have to train them. So then we have a pool of experts to hire. Then what kind of courses you have, what kind of courses we have, and we figure out that there is no such study program at the moment to train this kind of people. So then I think that is something we are still working on. We hope that there will be people, because only when we have such people, this industry in Finland will grow, because at the moment there are very, very few companies working in this field in Finland. I mean, especially come to this. To my understanding, if I remember correctly, there is still only one company at the moment, and I think if we have more experts, this industry will also grow.
Now I'll ask a couple questions from the audience. The first one is, do you have any concern at all putting all these sensors and electrical devices so close to the human body?
Well, and of course, when this it become the garment, it need to fulfill all this electronic safety and also other kind of I would say requirement or regulation there. But I would say, when you put the smart watches there, or if you put the smart glasses there, people usually don't ask this question, right? And then now the only change is that, okay, if you think about this garment, these yarns, there is basically no difference from the cotton or the wool we have. The only thing is that at the moment, this, because it's in a prototype phase, so this kind of electronic, like a microcontroller or these wires, you still see them. So you start feel like, oh, we are getting electric shock there. But I can say that when it comes to the product level, you don't need to worry about that for sure, So it could be something nice and compact, and you can remove that. It would be the same as you putting a smartwatch, because watch is also touching there. And also there are actually other sensors, for example, for glucose monitoring. They even have a small needle that go into your skin, but this doesn't have. So I think that's just because we don't have so many commercial products yet, so people have all kinds of concerns. But when they are products, you will not see it as electronic devices, for sure. Yeah.
Okay, and the last question is, what is your team currently focusing on after the sauna suit project? What upcoming initiatives are you exploring, and what kind of expertise or opportunities might you be looking from a research perspective?
As I said, now we have a couple of things. So, for example, from the AI perspective, we are working on the AI-driven design. So how to make the AI-driven design, and we also look into more explainable AI when it comes to the motion tracking or physical activity analysis. And on the garment side, we continue the sensor development there. So we need also people who know how to do knitting or weaving or sewing there. But for the haptic, we have now some plan. For example, actually, in the project, we not just make our own garment, we make the open source platform, both hardware and software open source. And then other research group have utilized ours to make something for example, for low back pain, the rehabilitation, or for this more like a VR entertainment. So others have been using that. And we are also discussing with the colleague that we could utilize this haptic, for example, for ADHD treatment. So you don't need to use certain medicine, but use that to help people to focus and things like that. So that's like a new application is something we are also exploring when it comes to the haptic. Other kind of healthcare or well-being related applications.
Thank you so much. It's been really interesting to hear about your research and your thoughts on the whole topic. I'm sure that everybody here in Marcio and online watching the stream got many new ideas and thoughts.
Great to hear. Yeah, thank you. Also, thank you for inviting me here.
You can stay there for a little while.
Okay.
In our digitally augmented world, we need to ensure that technology truly enriches our lives. Researchers like Yu Xiao unite different disciplines to develop new methods and use cases for digital technologies that keep human experience at the center of it all. Just a reminder, please do check out the MAGICS website for more details. And thank you, everyone, here and online for joining us. Until next time, thank you.